Today we are going through the next lesson, which is the x and y coordinates of an exponential graph. So an exponential graph is basically a graph where its variable x is in the power of the equation. So let's look at the general form, right, which is right here. On this line here, the general form of an exponential graph is y equals a to the power of x. So again, my x is my power, where a is a constant, meaning any other number, it can be 2, -2, whatsoever, right? An exponential graph basically looks like the following, right? It goes up, but it never reaches 0, and it just keeps going up. It just goes exponentially. A good way of talking about an exponential graph is basically, in financial math, we normally get asked, well, okay, you got two options. One option where you get $1 million per day, or the other option, which is $1 on one day, $2 on the other day, $4 on the next, $8 on the next, and so on. So it doubles, right? So that doubling choice is an exponential graph. It will grow increasingly large, right? No matter what number you pick. But the smaller the number, the closer it gets to 0, but never touches 0. It never passes, it never touches. Okay, so that is the general form of an exponential graph. One thing that is really, really interesting about an exponential graph is this term called the asymptote. Right, so the asymptote is basically a straight line that a curve approaches, so it gets really close to, but never crosses. Never crosses, never touch. So in particular, this graph right here, okay, the asymptote of this, you can just basically see it. The asymptote of this is basically the x-axis, okay? The equation of this asymptote will just be x equals to 0. Okay, so that's the asymptote. The graph, which is in the green, gets close to 0, never touches it. Right? That is a very important term for you to remember. Okay. Now let's go into our example number 1. Complete this table of values for y equals 2 to the power of x. So for this one right here, same thing like what we did before in our parabola. I'm just going to sub it in. So if my formula is this, -3, so x equals -3, I'm going to put it in. I'm just going to put into the calculator 2 to the power of -3. And that should give me, let's just put that into the calculator, should give me 1/8. If your calculator comes up with a decimal, just press the SD button, which is above the delete button. Okay, that will change it from a decimal to a fraction, or a fraction to a decimal. All right, so what I'm going to do is I'm going to write down 1/8. I'm going to do the exact same thing for -2. That should give me 1/4. This one should give me, I think, 1/2. This one should give me 1, which is very, very interesting. Then this will be 2. This should be 4. This should be 8. All right, done that. Super easy. Just use your calculator. Question B. Graph the values from the table on a Cartesian plane. So I've done my Cartesian plane. Again, just to note, make sure your increments are correct. You can go up by 1s, you can go up by 2s, you can go up by 5s. Okay, up to you. All right, let's do it. So just going to look at this column right here. This column will have a coordinate of -3, 1/8. Okay, so -3, 1/8. What I'm going to do is I'm going to write down, this is about -3, and I'll just put a dot there. Let's say that's 1/8. Then I've got -2, which is a quarter. Let's say I'll just put it there. -1, let's say it's there, -0, x equals to 0. My coin will be 0, 1. Should be, let's say, here. Honestly, just do your best when you're graphing these. It's a bit tedious, but it's fine. This will be here. Oh, sorry, that's not 1. Should be around here. 2, 4. Right here. See how it goes up really fast. 3 will be then 8. Right here. So how I'm going to draw it is basically like so. Done. Okay. Once again, don't forget to label. This will be y equals 2x. 2 to the power of x. Just like so. I'm done. All right, let's look at question number C. Are there any negatives values for y? Okay, let's look at the graph. No. So I'm going to write down no. Now my explanation is this, right? You know how we're talking about the asymptote, right? And you can see from this graph, it never reaches 0. So it never passes 0 to go down to the negative. So what you're going to say is, well, there aren't any negative values for y because the asymptote is x equal to 0. Thus, the graph y equals 2x does not pass 0. That's it. All right. Simple as that. Let's go to question D. What happens to the value of y as x gets larger? All right, let's look at the graph. Okay. If I had x equals to 5 around here or so, let's say around here. Okay. And if you try and predict it, right, that graph will just continue on and get larger. The y value will just get larger. And you can already see it here when it's 3. It'll be 4, then, sorry, this should be 2. Then if it was 3, it'll be 8, right? It just gets larger and larger. So what you're going to write down is the y gets extremely larger. Okay, that's it. All right, what happens to the value of y as x gets smaller? So like a -5 or -2 and so on. Well, we can see it right here, right? If it gets to -2, it keeps getting closer to the y value, sorry, the x-axis, but never touches. So what you're going to write down is very simple. The y value gets smaller, but never reaches 0. Never reaches, never passes. All right, last question. What is the equation of the asymptote? I think we already did this. The equation of the asymptote, if we look at the graph once more, my asymptote is just basically the x-axis, right? The graph never touches or never passes the x-axis. So this equation is x equal to 0. Okay. So what I'm going to do is very simply going to write it down here. X equal to 0. That's my equation of my asymptote. Hopefully that makes sense, and I'll see you in the next video. Bye.